Yes, my dear students, hoping that you are fine. So we are right now solving paper 6 variant 2 of May-June 2016. May-June 2016, as usual, the time allowed for this paper is 1 hour and marks are 40 for this exam. And this is only 20% of the curve or the weightage of the curve, you can say, of our syllabus. So let's start without any delay. So question number 1. A student is investigating the stretching of a spring. Stretching of a spring. And we have to do what? We have to measure the stretching of this spring and so on. So in figure 1.1, measure the unstretched length LO of the spring. Record LO in the first row of the table 1.1. So what to do? You will place your ruler vertically and very close to this point and you will measure this length. And when we are measuring this length, my dear friends, with the help of a ruler, so it comes to be 5.5 centimeters almost. So almost I'm writing nearly equal to 5.5 centimeters. So we have to put this value into the table. Now here, see, keep your eyes open. You cannot write here 5.5, that is in centimeter, and these values are in what? Millimeters. So it means 5.5 times 10, convert it into millimeters, and this will become 55 millimeters. So here we are supposed to write 55 without any delay. Okay, so 55. Be careful, we need to convert it from centimeters to meters. Now the student hangs a load of 1 Newton. See, this one is the original length. By the way, if you ask me, this is the original length, LO. Of the spring, the student hangs a load of 1 Newton on the spring and measure the new length of the spring. She repeats the measurements by using the loads of 2, 3, 4, and 5 Newton. The readings are shown in the table 1.1. So all the readings are shown. Now, he is going to investigate the stretching of the spring. So it means we will be planning to plot a graph so that we can reach a conclusion, and then we can analyze a graph by the shape of the graph, the gradient of the graph, and a lot of things. So same here, my dear friends, what we are going to do, we are going to now, the values are put there. For each set of readings, calculate the extension of the spring using the equation E is equal to L minus LO. This one is LO and all other values are L. So 59 minus 54, that is, my dear friends, 4. Then 64 minus 55. 64 minus 55, we are getting 9. Then 69 minus again 54, that is equal to 15. Then 74 minus 55, it is 19. And 78 minus 55, that is 23. Dear friends, every time we are taking LO 55 and measuring the values. And always remember, here they mention very clearly, but sometimes they are not telling it. Always remember that whenever we are in the phase of this extension or Hooke's law experiments and we need to plot a graph, we need to find the extension, there will be one length which will be just the original length. And how do we know that this is the original length, unstretched length? Simply by looking when there is no load, it means the spring is hanging without any extension, like this case. So we are measuring the spring length and there is no load attached. This one will be the LO, our original length. Sometimes we call it X1. Here they said to use it as LO, very clearly mentioned, you can see here. And then We keep on adding the load and the spring keep on stretching, and see the numerical values are there, and we are calculating an extension and the equation is given. So the good thing about this paper is that always the formula to calculate or equation to calculate the value is given. Now, X briefly one precaution that you would take in order to obtain reliable readings. You are using the meter rule to measure these readings. So whenever you are using meter rule, so one thing very important, place the ruler close to the spring, or even the best one is view the scale at 90 degree, mean to avoid parallax error. So view the scale or ruler at what? 90 degrees. That is the best answer wherever the use of this wherever the use of this scale is there, or some analog meter is there like voltmeter, ammeter, which is not digital, not in terms of numbers, only a pointer is there. So my dear friends, we need to solve it. We need to improve it by looking the scale at 90 degree and to avoid parallax error. And also let me tell you, if you are writing here, avoid parallax error, you will be given 0 mark, because only writing parallax error is not enough. You have to actually explain it. How to overcome that parallax error? Parallax error means you are not looking the scale at 90 degree. And always I'm giving an example because we know we all have that experience sitting in a car, and if the speedometer of the car is analog, mean with the pointer that starts in rising from 0 to 100 and 120 and 140, whatever the speed of the car you are driving with. So uh, the driver only can see the speed, or can measure the speed, or can note the speed correctly, because he is sitting exactly in front of the scale and his line of sight is 90 degree. But for any passenger who is on the front seat beside the driver, he is not looking the scale. He cannot look the scale 90 degree by keeping on his place, by sitting on his seat. So he will be committing the parallax error, and answer will never be accurate. So this point you need to understand and you need to know very well. So wherever, dear friends, we are dealing with the measurement with the ruler or any analog meter. So improvement is view the scale at 90 degree. Our line of sight should be at 90 degree. Now, plot a graph of extension in millimeters on y-axis and load on x-axis. I will just little bit squeeze it. So now extension in millimeters on y-axis and load in Newton on x-axis. By writing so, we have scored the first mark. What we have done, we have scored the first mark just by writing this, my dear friends. Okay, so now what is next? We need to place the data on y-axis as well as on x-axis, but it should be spreading, or it should be covering more than half of the grid. More than what? Half of the grid. So what do I mean by more than half of the grid? Like see, 1, 2, 3, 4, 5, and 6 boxes are there on squares are there on y-axis, big squares. So my data should be placed at least at 4 squares, so that more than half of the grid is covered. Similarly here 1, 2, 3, 4, 5, and 6. So here also at least 4. So load is 0 to 5. First of all, it's quite easy to put the load here. 1 Newton, 2 Newton, 3 Newton, 4 Newton, and 5 Newton. Yes, this is covering more than half of the grid. Now, our extension starts from 0 till 23. It's also very easy. See, 23 means 25. 5 5s are 25. So, see, simply, what can we do? 0 here, 5, 10.0, 15.0, 20.0, and 25.0. Now see, our second mark is also scored The reason for that, because our data is scattered on more than half of the grid. On more than what? Half of the grid. So we have scored our second mark also. Now we have to locate the positions of these points, this data. So what to do now? But here, see, this is 0, 1, 2, 3, 4, quite clear. So our first cross, and it is recommended better you should use the crosses in place of uh, dots. If you're using dots, then it should be in, dots should be in, my dear friends, uh, placed in a circle. Okay. Now, one thing, this is 5 boxes. You know, what is one small square representing on y-axis? That is 5 minus 0 over 10. So it means each small square represents 0.5 millimeter. So two small squares on y-axis is equal to 1. Now, at 1, extension is 4. We need to plot a graph, load and extension. So 4, and then at 2 it is 9. So 4. At 1 it is 4. See, this is 5, 2 boxes below. So this way. Then at 2 it is 9. Again 10 and 9 is here. So this is 9. At 3 it is 15. At 4 it is 19. 3 it is 15. So very simple here. 3 is 15. 4 is 19. So 19 means just 2 boxes below 20. And at 5 it is 23. So oops, I don't did it wrongly. This is 24. No, it is 19. At 3 it is 19, and then 23. 3 it is 4 it is 19, sorry. So 19 is here. And 5 it is 23. So this is 23, which is, see, 21, 22, and 23. Two boxes equal to 1. Now we need to plot up. This is the third mark we have scored. Okay. My dear friends, if you are using the dots, then dot should be in a circle. Lazim, remember it. Dot should be in circle, but better you can go with this uh, cross signs. Now, you have to draw the line best fit. You can draw the line, and the thickness of the line should also be very thin. It should not be thicker than this big square like these lines. It should not take from them. Okay, now I'm going to draw the line of best fit here, my dear friends. This is the line of best fit. You can even make it more better because I'm not using the scale, just randomly I'm drawing it. So in this way, we have scored our all 4 marks. Again, I'm repeating, how can we score our all 4 marks? My dear friends, the method is, first of all, label the axis accordingly. Label the axis accordingly. Like it was told that extension in millimeters on y-axis and load in Newton on x-axis. This was our first one. Second mark was we need to place the data on x-axis and y-axis such that it is covering more than half of the grid. More than half of the grid. Second mark. Third mark, we will locate the positions of these points, and that will be our third mark. And then drawing a straight line in case of graph, sometimes freehand curve, that will come only in case of cooling experiments in thermal physics if they are part of the question paper anyhow. So then the graph line, but please be very careful. The graph line should be not thicker than the big square line. So it should be very thin. So better it is recommended that use mechanical pencil 0.5 or 0.3 mm. That will be more suitable to do this job. Okay. Now, the student removes the load from the spring and hangs an unknown load X on the spring. She measures the length of the spring to be 72 millimeters. Now, calculate the extension E of the spring. No problem. Extension E is equal to L minus LO. L is 72 and LO is 55. Oh, we know this already. That's what we measured in the beginning. So that is LO, which is in bracket up there, black bracket on both sides. That is 55. So 72 minus 55. What we are getting? We are getting 17. So what is the extension in this case? That is 17, but don't sleep. If you will not write millimeter, it means you are going to lose the mark. Because unit is needed wherever it is available. Correct unit is needed. Now use the graph to determine the weight W of the load X. Load X. Show clearly on the graph how you obtain the necessary information. Now what is the extension? Extension is 17. We need to locate where is the extension 17. See, this is 10, this is 15. 1, 2, 3, 4. Here it is 17, my dear friends. This is how much? This one is 17 millimeters. So we need to know the load. So this is extension. So load will be just pick up your ruler, draw the dotted line, keep on stretching it till it touches the graph. It touches the graph over here. Then again, use the ruler. Over here. Now, what is the load? This is 3.1, 3.2, 3.3, 3.4, 3.5, and this is what? 3.6. So, my dear friends, here, this is how much? 3.6 Newton. And you can write here how much? 3.6. And don't forget to write the unit, which is Newton. And it was very clearly mentioned that show clearly on the graph that how did you get the necessary information. So first of all, we located 17 on extension axis because when unknown load was attached on the spring, the length of the spring increased to 72. Then we calculated the extension that came to be 17 millimeter. So we will first locate on extension axis, which is y-axis, where is 17 millimeter, then a horizontal line, then wherever the horizontal line intersects with the graph, from there then vertical line downward till it cuts the or intersects the load axis or weight axis, and we can get the answer. Anybody having any problem till now, please feel free. You people can ask me. Ahmad Murtada, anybody, please. Okay, now let's start with the next question. Question number 2. A student is using a balancing method for what purpose? To determine the weight of a piece of soft modeling clay. The apparatus is shown in figure 2.1. Balancing method. P is a metal cube of weight 1 Newton. Q is a piece of soft modeling clay. The student places the cube P so that its weight acts at a distance x from the pivot. Okay. He adjusts the position of Q to balance the rule and measures the distance y from the center of Q to the pivot. Then he calculates the weight W of Q using the equation W is equal to Px over y. On figure 2.1, mark clearly the distance x. What is distance x? See, it was mentioned the student places cube P and it's so that its weight x at a distance x from the pivot. From here, first of all, it is strongly recommended you should mark the center of this weight. Now, my dear friends, from here till here, this is what? This is x. Very clearly, cube P so that it weight act at a distance x from the pivot. So just a change to Q that would make it easier to find the value of y accurately. The problem is, see the load Q, load P, it is a regular shape. Q is a zigzag shape. It is not zigzag, I should say random shape, irregular shape. So what should I do? We should, my dear friends, write that mold the soft modeling clay to a rectangular shape like P. Make or convert Q to a regular shape. And why we can convert or change? Because we can to a regular shape. For example, cube. Instead of saying convert, you can say mold because this is modeling clay, so we can mold it into different. What are the spellings of mold? Is it okay? M-O-L-D or M-O-U-L-D? Yes, dear friends. Nobody is responding. Okay, mold. Then fine. American says MOLD and MOULD in British, so we have to go and take exam in British curriculum, so MOULD. Mold. Q to a regular shape like cube because it is not regular shape. See, I have measured this distance x from the center of the block T to the pivot. Okay. It is difficult to achieve exact balancing of the meter rule in this type of experiment. This can make the result unreliable. Explain how you would reduce the effect of this problem to improve the stability of the experiment. Balancing, you have performed this experiment, of course, in labs. It is difficult to achieve perfect balancing. Okay. So in such cases, what can we do? We can repeat the experiment and then take the average. So average result, repeat the experiment and take repeat the experiment and take average. What does it mean? When you are trying to balance, one side tips down, then the other side goes and tips down, it keep on oscillating. And sometimes one side tips more down, other side tips down, but less. So in this way, it means we are not able to get the exact balancing of this meter rule in this sort of experiment. So what to do? Repeat the experiment 2, 3 times and then find the average result. That will be a way to get accurate results in this sort of experiments. Now, the metal cube P is larger than the width of the meter rule. This is very important. Explain briefly how you would determine the reading of the meter rule scale at the position of the center of mass P. You may draw a diagram. You may draw a diagram. Now, what to do here, my dear friends? This is very important. This is very, very, very important. Let me just see. I have placed one scale with me and I want to share it with you with the help of a scale. Just a minute, okay? Just a moment. My dear friends, now see, I will share with you a scale and what is the question actually you will understand, inshallah, and then we can answer it. Then we can answer it very well. Now see, this is a ruler. And I'm picking even this calculator. What is written that metal, this is also a metal cube, by the way. So when I'm placing this calculator over this ruler, please you can see this is a bit uh, hard to see the ruler. See, this one is the ruler you can see. Now check. The diameter of this this calculator, just like they said for over their cube, is greater than the diameter of the ruler. How to get where is the center of this ruler? Okay, so if you carefully see this side of the scale on the edge of the calculator is 6 centimeters, and when I'm looking at here on the other side, this is at 14. You know, where is the center of this calculator on the ruler? So we will make it 6 plus 14 divided by 2. It means 20 by 2. It means the center of the calculator on this ruler is at 10 centimeter. Again, let's read the question. This is very important and we have to write in our own words. But wait a minute. The metal cube P is larger than the width of the meter rule. Now see, the meter rule width is this. And the width of this cube, let's suppose this calculator is acting as a cube. It is much more than the diameter of this ruler, meter rule. So what to do? Measure the length on one edge like this one, x1, this is 14. Check over here, this is 6. So what to do? 6 plus 14 divided by 2. This will give us the center, like it means 6 plus 4, 10, and here 14 minus 4 is also what? 10. So the center of this cube or calculator on this ruler is 10. So measure the value again on one end on the ruler, measure the value on the other end, then add them together, divide by 2. You will get the center of that object on the ruler. Please, dear friends, anybody having any confusion, now ask me, then I will be writing this one in the answer. If anybody is having the confusion, you can ask me so that I can repeat it. Otherwise, I will stop the video and we will proceed forward. Please, waiting for your response. If there is any query or question regarding this, please feel free. You people can ask me. So always this sort of question, any question like this, that diameter of the object is bigger than the diameter of the ruler. So what to do? Place the object on the ruler, measure the length on both the edges of the ruler on both the edges of the object on the ruler, then add them together, divide by 2. This will give us what? The center of that object on the ruler. I'm sure this is okay with you all. So now let's write the answer for this part. So I'm going to right now take the readings on both sides of the cube. That's what we did here. It is a cube. So take the readings on both sides of the cube. Take the readings on both sides of the cube, like 6 and 14, and then find the mean or average. The average and find the average, get center of cube on the meter rule. That's what can be the perfect answer to understand it. No, 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 that is something different. Here, we are not talking about Zen, we are not talking about here about the accuracy of the meter rule. We will, of course, take meter rule which is accurate, which is having proper readings on it. So now actually here, what to do? So that's what is the here, how to get the center of that object. which is wider than the width of the meter rule. That's what we have to do. I'm sure this is clear with everybody. Now, before starting the experiment, the student determine the position of the center of mass of the meter rule. Explain briefly how you would do this. This is also very simple, but even when I was explaining this topic in the general physics, so we have discussed it. First of all, I will be writing the answer and then I will be explaining you. So place the meter rule, place the meter rule on pivot without masses. You know, right now P and Q are there. No, without masses. Without masses, even I can write P and Q and then find what? And then find the balance point. Which is center of mass meter rule. Okay, now, my dear friends, before I explain you, see, this is center of mass, but now they will not ask you center of mass, they will ask you center of gravity. Same thing you will do, that place the meter rule on the pivot. Now here, check, this is the meter rule, means small scale, and also it is recommended that when you are going for the external exams, you will carry this one with you to plot the scale in exam. This is 20 centimeter, even if 30 centimeter you can carry with you in a pouch that will be transparent. Transparent pouch. You cannot take your pouches like with the leather or some other resin, something like that. Okay. Now, this is the meter rule. Center of mass and center of gravity of the body is the same point. But if it is center of mass, it means it is the point in a body where whole mass of the body seems to act, appears to act. They will not ask you anymore the center of mass. No, they will ask you about the center of gravity. So it is the point in a body where the whole weight of the body appears to act, seems to act. Okay. And if the body is supported at this point, it will not rotate, it will stand still. Just open my notes and you will get this one. Now see here right now. Let's suppose this is 20 centimeter and my finger is acting as a pivot. Now see, place the ruler on the pivot where it is balances. Now the point where my finger is supporting this rule, that point is basically the center of mass or center of gravity of this ruler. That's what I wrote, that place the meter rule on pivot. Right now my finger was acting as a pivot without any masses. Why we are writing without any masses? Come here. In the question, actually, P and Q masses are given. When you are finding the center of gravity of this meter rule, in this paper, this is center of mass. No, they will not ask center of mass, center of gravity only. So without the masses, like I have done now, see, I have placed it at 10. It is not balanced still, little bit movement. And now almost it is what? Balanced. Okay, so place the meter rule on the pivot without masses P and Q and find the balance point, which is the center of mass of the meter rule. Why did I choose this old paper? Because there were these things which we did not discuss in the new exams. So they can bring these things, how to get the center of an object which is wider than the width of the meter rule and how to get the balance point. Like these things, they are comparatively not repeated in last few years. They may come because part of syllabus. That's why I have chosen this paper. Anybody having any question here regarding this all, please feel free. You can ask me. Otherwise, I will be moving forward. Okay, I'm moving forward. If the question, I will be coming back. Now, this is the question on, again, lenses. A student is investigating the magnification of images produced by a lens. The apparatus is shown in figure 3.1. 3.1. And always you should be very good. We should be very clear to know to draw this diagram if it is not mentioned. So what is the mechanism or arrangement of this diagram? Sorry, the arrangement of this diagram, it is that lens is in the center, object is on the extreme left, illuminated object, and screen is on the extreme right. Okay, so now A is the distance of the object from the center of the lens. B is the distance of the image from the center of the lens. Yes, this is screen, but dear friends, the image is made on this screen. Okay, now the student places the screen at a distance D is equal to 80 centimeters from the illuminated object. So this distance is basically 80 centimeters. The screen and the illuminated object remains in the same position throughout the experiment. So this one and this one, they are fixed. Only the lens can be moved in this experiment. So she places the lens close to the illuminated object. She moves the lens until she sees a sharply focused and enlarged image of an object on the screen. If she's seeing the screen image on the screen, it means that is a real image. Okay. So she measured the distance from the illuminated object to the center of the lens, and that is 20.3 centimeters. This one is told 20.3 centimeters. She measured the distance B from the center of the lens to the screen, and that is 59.7 centimeters. 59.7 centimeters. So calculate the magnification M1 of the image using this equation. So formula is always given. So magnification M, this is B, which is 59.7. Now don't start rounding it off. No need. Centimeters over 20.3 centimeters. Now, when we are calculating it, 59.7 over 20.3, I'm getting 2.940. So answer is 2.9 here, 2.940 centimeters, and I can write it here in one decimal place or two significant figures, centimeters. Please, my dear friends, if there is any question or query, feel free and ask me. Ali Yusuf, Ahmad Murtada, Lana, Aham, Abdul Rafi, Uzair, Zain, anybody having any question here, please feel free and you can ask me now. Or maybe I did some mistake. Please check if I have done some mistake. There is a possibility that I have done some mistake. Yes, concept is clear, but I have committed one mistake and nobody is telling me what is that. Yes, Mohan, you are correct. So, my dear friends, please, no need to sleep at all. Here, I wrote intentionally the units. Centimeter is cancelled with centimeter. So, why am I writing this centimeter here? So, only the answer is this one, 2.9, no unit. Because, okay, in your syllabus, no, there are only two quantities which are without any unit, and both are in physics of waves. One is the refractive index, that is sine of angle of incidence over sine of angle of refraction. So the unit of angle is degrees. So degree in numerator, degree in denominator cancelled. Speed of light in air over speed of light in medium, meters per second over meters per second cancel. So refractive index has no unit. And they asked in paper 4 once that why refractive index has no unit. And I told while I was teaching that refractive index has no unit because it is a ratio, but between two same quantities like angle over angle, length over length, speed over speed. So then there will be no unit. And second quantity is also from physics of waves, which is magnification, talking about how much the image is enlarged from the object, how many times it is bigger than the object, magnification. This is also having no unit. Again, why it is not having a unit? Because it is a ratio between two same quantities. Don't be fooled. Don't write only it is a ratio. Speed is also a ratio of distance to time. Current is also a ratio of charge to time. They have unit. But they have units because numerator and denominator are two different quantities. Magnification, length over length, size over size. So centimeter cancel. So magnification has no unit. Okay. Why? Because it is a ratio between two same quantities, just like refractive index denoted by letter N is also having no unit because that is also a ratio between two same quantities. Let's move forward. Now, the student then moves the lens towards the screen until a smaller, sharply focused image of the object is seen on the screen. So she measured the distance x from the illuminated object to the center of the lens. Y is this, and now M2. That is equal to y over x. So it means now 19.8 over 60.2. When I'm trying to calculate it, so dear friends, 19.8 divided by 60.2, and answer is what? 0.328. What is the answer? Answer is 0.328. I have written this value of magnification to two significant figures. So I cannot use here 3. Here also I will be consistent with the number of significant figures. I will make it 0.33, and again there will be no unit. The reason for that, centimeter here and centimeter here, they are cancelled. Okay. Now, another thing, see, the total distance was 80. This D was told that it is 80 centimeter. D was from the screen to the object, and the screen and object, they are fixed. Only the lens is moved. If you add now here, my dear friends, like 59.7 plus 20.3, it is equal to 80. Similarly, if I'm going to add here 60.2 plus 19.8, this is also equal to 80. So the distance between the lens, sorry, between the screen and the object is not changed. Only the lens is being moved forward and backward to get these distinct and sharp images. A student suggests that M1 and M2 should be equal to 1. M1 and M2 should be equal to 1. Statement and justification. State whether the results support this suggestion. Justify your answer by reference to the results. So let's calculate M1 times M2. M1 was 2.9 and M2 is 0.33. Let's check it out. So 2.9 times 0.33, what we are getting? That is 0.957. This is equal to 0.957. So that can be written 0.96, and that is nearly equal to 1.0. So statement yes, and we will say within the limit of experimental accuracy, and I will explain you, wait a minute, within the limit of experimental accuracy. Mean if your answer is more than 90% correct, it means it is within the limit of experimental accuracy, and we will consider the answer as the correct answer. Okay, so we will consider the answer as what? Correct answer. Now, please, all of you, just check it, and then I will be calculating the percentage error to check either it is within above 90% or no. Okay, my dear friends. Now, see here. Let's calculate the percentage error for this experiment. In general, that is not needed because already they are very close, but still, let's calculate the percentage error or uncertainty. And the rule is 2 times 1 minus 0.957, I think. They said it should be 1, but our answer is 0.957. So sum of the quantities, sorry, difference of the quantities in the numerator and sum of the quantities in the denominator times 100 to get how much percentage is this. So let's calculate. So I'm doing 2 times, that is 1 minus 0.957 over 1 plus 0.957 times 100. And as I'm checking it, it is 4.39. It is how much percent? It is simply 4.39, we can say simply 4.4% inaccuracy, percentage error. So 4.4, if it is subtracted from 100, it is 95.6% correct answer. So yes, it is high ratio of accuracy. So the answer is correct. Okay. So, but it was very close. So that's why even I did not calculate and I wrote yes within the limit of experimental accuracy. Let's suppose this percentage error with some other data when we were calculating, it was 14.4. Then I was going to write here no in statement, and in statement no need to give a lot of detail. Yes or no only. That is enough. And I was going to write no in case if it was 14.4% and outside the limit of experimental accuracy, because the accuracy of the experiment in case of 14.4, it will be almost 85% less than 90%. Now, precautions, stage two precaution that you would take in this experiment to obtain what? To obtain the reliable result. Many, I told you people. So in this experiment, the first one which you can use, perform the experiment in dark room. That's what I told you already. Perform the experiment in dark room or shaded area. Both the ways it's okay. Why? So that image is well focused. We can observe the image very well. And I'm always giving this example as the principal examiner used to give this example whenever he was explaining this question. Like you are in an auditorium in some conference, the places where the audience are sitting, so that is dark or very light, very dim light, while on the stage where the speaker is addressing you people are sharing his experiences, so that dice is brighter, there is a bright light, or even if the dim light is there, but there will be a beam of light falling on the speaker so that you can focus more, concentrate more. And same is the case here. If you are going to get the sharp focused image, so in bright light, it will be very difficult to mark the boundaries of that image. But if it is darkness, it will become quite easy to do that, to do so. Secondly, even if you remember that even a simple cameraman, I'm always giving this example, like I want to take my selfie here. Okay, so not here. I will move bit closer this way. I will change like this. So same is the case when a cameraman or a photographer is going to take the images. So he is moving the lens of the camera forward or backward very slowly so that where he will find the image is well defined, focused, sure, he will turn on the flash. So that point I'm going to write. Okay, but listen carefully one thing. Sometime we are writing, last time I think in the previous weeks I solved this question, this sort of question on lenses. I used move the screen forward and backward slowly because in that case screen was being moved. But you have to be very much vigilant and attentive. Here, the student places a screen and this screen at the same position. Then she places the lens close to the illuminated object where I'm reading. You may be thinking, sir, what you are reading? Close to the illuminated object. She moves the lens. So here it is mentioned into the question that what we have to move. This is, we will be moving no lens because the screen position and the object position, they are both fixed. Okay. So move the lens forward and backward slowly to get the short or focused image. That is the second point which I'm going to write now. Move the lens slowly. Move the lens forward and backward. You can also write to and fro. Forward and backward to get focused image. Okay, so these two points. Now wait, you may think that I have already shared with you some data, my dear friends. Now that's not there. Now, these points are already written and I shared with you that file. If you want, I can share it again. So for lenses experiment here, yeah, here. Now see, accuracy, this is point mentioned here. Accuracy or reliability light experiment using object, screen, and lenses. Perform experiment in dark room or shaded area. Move the lens forward or backward, even sometimes screen, slowly to get the focused image. These 2 points I wrote. Object, lens, and screen should be perpendicular to the bench or table. They should not be tilted. All the distances should be taken from the marked center of the lens and ensure that each item is aligned so that the center of each item is same height as on the same horizontal optical axis. That's what I explained you already. What does this mean? This point, same height. Come here, dear friends, that it's not possible that your lens is here. So that will become useless, the lens here, or object is down here. That will, so they should be all at the same height almost. And it is believed, and it is a better approach to say that the center of the object, center of the lens, and center of the screen, they are at same height from the bench or table. So that's what these are some points to maintain or to get accuracy in this sort of experiment. Okay. So now next, suggest one reason why it is difficult in this type of experiment to decide the best position of the lens to obtain sharply focused image. You know that best position of the image is in a very short range, is in a very small place. So I will say that well focused image appears over a very small range of the lens position, over a very small range of lens position. And if you are writing screens in screen position, so that's why we are moving it forward and backward very slowly. Okay, so now let's move forward, and that is the planning question. From this year this planning question was introduced. Okay, let's see it now. Dear friends, here now a student is investigating how the resistance of a wire depends on the length of the wire. And we have discussed it already, many MCQs, many paper 4 question. Resistance is directly proportional to length, but just we have to investigate it now. The student aims to plot a graph. Now, if student aims to plot a graph, so at least he should have a 5 sets of data. So 5 readings for the length and 5 different readings for the resistance for every corresponding length, at least. Okay. The following apparatus is available to the student: ammeter, voltmeter, power supply, variable resistor, switch, connecting leads. Now, resistance wires of different length are already given and a meter rule to measure their lengths. Plan an experiment to investigate how the resistance of a wire depends on the length of the wire. Here, where he's saying plan an experiment, from here, my dear friends, you have to decide which one is independent variable and which one is dependent variable. My dear friends, first of all, independent variable is the variable which is changed by the student or by the teacher while performing the experiment. So in this case, we will change the length of the wire. So it means length is basically independent variable. Independent variable. And because of the change in length, the resistance will change. So resistance is what? Resistance is dependent variable. Very important. Now you should draw a diagram of the circuit you could use to determine the resistance of the wire. Okay, no problem. Explain briefly how you would carry out the investigation. We will do. suggest a suitable length of the wire. It can be any length from 10 to 2 meters. So mean 10 centimeters to 200 centimeters. Key variable that you would control. Now see, length is investigated, diameter of the wire, type of wire. Like it cannot be possible that one length you are taking copper, other one you are taking aluminium, third one you are using gold or silver. No, same type of metal. And draw a table with column headings. Of course, table will be there. And table is always having these two: independent variable, the first column, and dependent variable, the last column. And also when you are repeating the experiment, this is always one mark in this experiment. Then repeating the experiment, what you are doing, you are changing the length, you are changing the independent variable, you are changing the magnitude of independent variable, and as a result you are getting the dependent variable and you are collecting more sets of data. So this is all scenario of this experiment. And don't try to be over smart, don't try to write extra. Whatever is asked, only focus on those points. Better to focus in order. Better to focus what? In the order as it is discussed. Okay, my dear friends, now let's start. First of all, we will start like writing the circuit diagram for the experiment is drawn below. Instead of writing given below, that is okay, is drawn below. So see, there is power supply, not a battery. There is what? Power supply, this. So what I'm going to do, I'm going to connect, my dear friends, first of all, power supply two small circles this way. Then of course, a switch is needed. Emitter is always in series. Then, my dear friends, leave a place where the length of the wire can be connected. And on this side, to control the size of the current, you should add one variable resistor that is there part of the slip, part of the diagram. Then, my dear friends, connect it over here. But one thing is still missing. What is that? We need to put the voltmeter that is always across the component. Now, dear friends, this one is what? Now label the diagram better. So I'm labeling it with another, like this is what? This is an emitter. Dear friends, this is a switch. This is the power supply. Then here is the variable resistor. Then this is the voltmeter. Then this is the length of metal wire, like this. Better to label it every point, okay? There is one query. Let me take, what is that? Okay, ma, no problem. You can leave. So watch this video, then it will be shared inshallah with you, okay? Now this is labeling. Labeling is done. Now what is next? And all the apparatus is arranged very well. What is that? That it is there and office. So what is there? See, emitter always should be in series. Voltmeter should be across the component where we need to measure the potential difference or voltage. Variable resistor is there to control the current. Power supply is of course there, and switch is there to turn on the current or whatever. Now, first of all, what we will do now, the next point is they want explain briefly, not in detail, how to would you carry out the investigation. So first of all, it is better here mention that independent variable, independent variable is length of metal wire, and dependent variable is the resistance of metal wires. Okay, now let's start. Uh, Now we will be talking about what to do next here. Now, first of all, close the switch. Close the switch so that current is turned on. Close the switch and hmm, should I close the switch? What about the measurement of the length? Hmm, Better to say, first of all, connect a measured length of metal wire. Connect a measured length of metal wire between C and D. I can make it. This is, let's suppose, C, and this point is what? D. Between C and D. Now, now you can write close the switch and measure current and voltage. Now, independent variable. Now, what we will do, we will say that repeat the same method. Repeat the, I'm using different colors to focus on different points. Repeat the same method by connecting. We will now talk about the independent variable by connecting metal wires of what? Of different lengths. Different metal wires of different lengths there between C and, so that we will be having more set of data. Then what is the next point? Suggest the suitable length of the wire lengths of wire can be from 10 centimeter to 100 centimeters. 5 values are, you can calculate in this way. Suitable lengths. Okay. Then, of course, what is the next point? Key variable that you will keep. Key variable. So two, we will say diameter of the wire and type of metal wire should be same. Diameter, in other words, even you can say area, you can say radius, diameter, and type of metal wire is kept constant. Constant are seen. Now, what is the next point here, friends? Next point is Draw a table and to show your display and your readings, and you are not required to enter any readings into the table as we are not performing this experiment. So how we can write the data are like this. So as I told you in the table, dependent and independent variable. Independent variable in the beginning, length of the wire in centimeters, then voltmeter reading in volts, current reading in amperes, and then resistance, which is dependent variable, that is in ohms. Why did I write this? I have written this V and I because resistance we will calculate by Ohm's law V over I. So that's why we need to mention this V and I along with their unit. So this is the table. Now, plot a graph better, to reach a conclusion. So one more point you can write, dear friends, that plot a graph of resistance against length to reach a conclusion. Mostly they will ask you so better to write this point also. And see, I have written resistance, which is dependent variable. Dependent variable is always on y-axis. So that's why it is better in the beginning to identify which is dependent and which is independent variable. So dependent variable on y-axis, length is independent, so that will be on x-axis. So plot a graph of R against L. It means R on y-axis and length on x-axis to reach a conclusion. And also this dependent and independent variable here, it will be independent first, the last one will be dependent. Even when you are repeating the experiment, then what you are changing? You are changing the by connecting metal wires of different lengths between C and D. So over there also dependent, independent variable is mentioned. I'm sure this will be very clear to you all. If anybody is having any question, please feel free. You can ask me, and in the meanwhile, I will be moving to the last question of this paper. That is, a student is investigating the cooling of water. Some of the apparatus is shown in figure. And here, my dear friends, one thing more, that in this question all, see there, I have used different colors so that accordingly you can just see the points and you will find every point is in different colors so that easy for you to mark and understand it. Okay. So rate of cooling or cooling of water. Now, the student pours 200 centimeter cube of hot water into 250 centimeter cube insulated beaker labeled A. See, this is insulated beaker. Some insulation is there so that heat should not be lost to the surroundings. He covers the top of the beaker with a lid. The student takes temperature every 30 seconds. As the water cools, the readings are shown in the table 5.1. First of all, the column, complete the column headings in the table. Time is in seconds. Temperature is in degrees Celsius. Temperature is in degrees Celsius. Degrees Celsius. So record the temperature at time t is equal to 0. Time t is equal to 0. He measured the temperature at t is equal to 0. So that is here. See, this is 80, 81, 82, 83. Please confirm if I'm wrong. 1, 2, 3. Yes, 83. So 83 here. Okay. So in this way, 2 marks you have scored. Now let's move forward. The student repeats the procedure using 250 centimeter cube beaker labeled B. This beaker is insulated but has no lid. Then he repeats the same again with 250 centimeter cube of beaker C. It has a lid but no insulation. All the readings are shown in table 5.1. Tick the statement that best describes the results of the investigation. It is cooling. First of all, dear friends, let's see how much temperature fall. Here, the delta theta temperature fall is 83 minus 71. 12 degrees Celsius. What about here? 85 minus 64. So 21 degrees Celsius. Here, 78 minus 64. 14 degrees Celsius. So now you can observe one thing. When the temperature lost is maximum or cooling is maximum, when the beaker be insulation but without lid. So no lid is there, rate of cooling is maximum. Okay, let's see. Removing the lid speeds up the rate of cooling significantly more than removing the insulation. I think this statement is correct. Why? Removing the lid speeds up. See, there is no lid here. Here is lid. Here is also lid. But no lid, maximum temperature fall is there. So yes, that is the correct statement. So removing the insulation speeds up, no. And there is no significant difference. No, there is a difference. So justify your answer by reference to the readings. So you can write the data there to get this answer. Now, so what can I do? I will say beaker A, delta theta. I will write all the values. Delta theta for beaker A, that is equal to 83 minus 71, only 12 degrees Celsius. Then delta theta for beaker B, that is equal to 85 minus 64. You have to give the results. 85 minus 64, that is equal to 21 degrees Celsius. And similarly, delta theta for beaker C, that is equal to 78 minus 64. So here it is maximum. State two of the condition that should be kept the same in this type of experiment in order for the comparison to be fair. So starting temperature and in room temperature, starting temperature, thickness of the lids, anything. So I'm writing here, first of all, room temperature, and already he kept the volume of water same. Room temperature, and even we can write starting temperature. Starting temperature of hot water basically. Hot. Suggest a suitable material for lid. Give a reason for your choice of the material. So of course it should be insulator. Like lid can be made up of wood. Why? It is a good insulator. That is very simple by the way. So lid should not be a metal. It should be non-metal insulator, so that it will prevent the loss of thermal energy from the hot water to the surroundings from the top by convection as well as by evaporation. And we know evaporation takes place from the surface of the liquid, whereas convection also hot liquid, which is less dense, it rises. So if there is a lid, it will prevent the uh, hot liquid in the vapors form to escape. So that's why this lid should be there, and lid should be made up of a metal. Next is now describe briefly how measuring cylinder is read in order to obtain a reliable value for the volume of the water. You may draw a diagram. I'm not going to draw the diagram. Already we discussed this. This is a very much repeated question. So what to do? We should view the scale of the measuring cylinder at 90 degree, and we should read it from the bottom of the meniscus. So number one, view the scale of measuring cylinder at 90 degree. Read the scale from the bottom of the meniscus. Bottom of the meniscus. What is that? That is the curved surface. This meniscus is bottom of the meniscus. of the liquid. So this way you can score all 2 marks. But if you want to draw it, you may draw a diagram. I don't think so they will give you the marks. Still, even then you have to write. But I can roughly draw it this way. This is always giving answer in centimeters cube, sorry, not only centimeters, centimeter cube. So there is a liquid inside and the line of sight should be like this. So it is at 90 degree and also at the bottom of the meniscus. Bottom of the meniscus, okay? This is water or something like that. So in this way, my dear friend, this paper is done and it was having more questions, but more detail. That's why I have chosen it. I'm sure this will be okay with you people. I will share the recording also, but after some time when it will be ready, prepared and converted into the MP version, any question you can ask me. And tomorrow I have a plan to solve paper 4. Tomorrow's lesson will be at 9, 10 p.m. after Tarawih prayer. And I will be preferring to solve paper 4. If any one of you are feeling difficult in a particular year, you can share with me on the group. I will be solving that particular paper 4 tomorrow, inshallah, at 9 or 9:10 p.m. after Tarawih prayer. Stay blessed, all of you. Have a nice day. Take care and assalamu alaikum.